Hey, you're in space, in a rocket, and you want to learn Newton's C laws of motion. Don't worry, buddy, I got you. If you look up Newton's first law, then you might come across something like this. But what does this science talk actually mean? Imagine our rocket here is moving 2000 meters per second. Then it stays at that speed unless another force, like an asteroid, acts upon it. This natural tendency to remain at constant momentum is called inertia. After Gravity Guy played in his backyard with some apples, he came to the conclusion that F is equal to ma. The key takeaway is that if you apply a force to a fixed mass, then you get a predictable amount of acceleration. Also note, if our rocket would have weighted less before the impact, its acceleration after the impact with the asteroid would have been higher. So the more mass an object has, the more force you need to apply in order to speed it up. The third law states that for every action there's an equal and opposite reaction. If a moving asteroid crashes into an asteroid which stays still, then both asteroids will take damage, even though only one of them was moving beforehand. I mean, if you punch a wall, then your hand takes damage too, even though you are punching the wall and not the other way around. The force which damages a moving asteroid and your hand is called the normal force. Okay, we now know what the three laws of motion are, but how do we apply them in our exams? I got you, buddy, again! For this example, we are heading back towards Earth, since that's the place where most of your exam questions are taking place. Purpleman from last video is pulling a 25 kg box with a force of 200 newtons at an angle of 30 degrees above the horizontal. The coefficient of friction between the box and the ground is 1 over the square root of 3. Let's find the box's acceleration from rest. The first thing you should always do in this kind of situations is to draw a free body diagram. Alright, we know that the weight pulls the box downward, and according to Newton's third law of motion, the normal force points upward. The friction, on the other hand, points to the left, opposite to the velocity. X is on the right side and Y is upward. We also have our pulling force P. Let's apply Newton's second law on the box. We have F equals ma for our horizontal and vertical forces. The sum of all horizontal forces is basically just P cosine of 30 degrees minus friction is equal to ma. But how come? It's because they point to opposite directions. The pulling force P is pointing towards X, which is why it is positive. The friction, on the other hand, points to the opposite direction, so it must be negative. Since cosine of 30 degrees is basically just the square root of 3 over 2, we get P times the square root of 3 over 2 minus friction is equal to ma. Now let's look at the y-axis, so the vertical forces. The normal force and P point up, while the weight points down, which is why we get P sine of 30 degrees plus the normal force minus the weight is equal to 0. Why is it 0? It's because the vertical acceleration is 0 due to the box laying on the ground. Sine of 30 degrees is 1 over 2, so we get the pulling force over 2 plus the normal force minus the weight is equal to 0. If we now plug everything in, then we get about 150 newtons for the normal force. Now we're gonna plug the normal force into the friction equation. The friction equation is basically just mu times the normal force. By plugging in the normal force, we get a friction force of 50 times the square root of 3 newtons. Alright, now we can finally substitute the friction force into the x equation. Cool, now we will divide by 25 and get our final acceleration. There are obviously other kind of examples, like with an incline or with chords, where we also have to take tension into account. So if you guys want me to cover this too in some YouTube shorts, then write that into the comments.